Okay, let's get started, please. I have some good news for you, and that is that you already have some experience with the basic building blocks of geometry. The basic building blocks of geometry are point, line, and plane. You're like, wait a minute, when did I use those? Well, you use those every single time you graphed a line in Algebra 1, and you did that a lot, right? So on the coordinate plane, which is like your piece of paper, which is nice and flat because it's sitting on a desk, you plotted points in order to graph lines. So, just as an example, see if you remember this. Let's graph the line with the equation y equals -2/5 x plus 4. So just as a quick reminder, and we'll do a more thorough reminder of this later in this semester. If y is equal to -2/5 x plus 4, the y-intercept is 4. So my line will go through the y-axis at 4. And the slope will be -2/5. That's the rate at which this line is going up or down. The negative means that it's going down, and it's going down at a rate of 2 spaces down for every 5 spaces it goes to the right. So 2 spaces down for every 5 spaces it goes to the right. Notice that since -2/5 is the same thing as 2 over -5, you could also, from this point, go up 2 and to the left 5. And it'll be on the same line. Okay? So from there, you just draw a line. By the way, I don't require that you get out a ruler every time you want to draw a line. Like, a sketch is fine for what we're doing. So, a question for you to think about for just a second, and then I'll ask for a volunteer. What's the least number of points you need in order to plot? You need to plot in order to graph a line. So what is the least number that you have to do that? Someone will raise their hand. Yes, sir.
2.
You got to have 2. Is it better sometimes if you have more?
Yeah.
It's easier to make it nice if you have more, but the least you have to have is 2. So the next question is, does a line end at any of the points you plotted to help you graph it?
No.
Does it end there? No. And the explanation for that is a line is infinite. I always find it funny that most students know the word infinite but don't know the word finite. Infinite is literally not finite, right? The number of chairs in this room is finite. The number of points on a line, it's fine, no big deal. No one heard it. It hardly made a noise at all. The number of points on a line is infinite. There's a whole bunch of them, more than you could ever count. So is there a limit to the number of points that can be on a line? No. There are an infinite number of points on a line. All right, let's move on to page 2. I'm going to turn this thing sideways. and make it a little bit smaller. So I use these from time to time. I've kind of fallen out of like with these. This is something that's called a Freyer model, which is a way of organizing all the information about a particular thing in one spot. Some people really like them. I used them for a while, and I used them kind of at the beginning of the year, and then I'm like, okay, I'm kind of done with those. So we're going to put what we're defining here. We're going to talk about a line. We're actually not going to define a line because a line actually has no definition. We understand what it is based on some things that we'll talk about, but there's no actual definition for it. So what do we know about a line? Well, a line is primarily, if you had to give a one-word description of a line, what's its most important characteristic?
Straight.
It's straight. A line is straight. More than that, something that you don't normally think about is that it has no thickness. So what you draw on your paper is actually not a line. It is a representation of a line. It's the best you can get. You're not using, one of those great big marks-a-lots where it's this huge fat thing. You typically use a pen or a pencil. But no matter how thin you draw it, a line is thinner than that. Okay? It has no thickness and extends infinitely in opposite directions. So, as an example, that's a line. Or at least that's the way we'll illustrate a line. We've already talked about the properties, that it's straight, that it has no thickness. We have to do that because we're describing it. We're not really defining it. What is it a subset of? Well, it's part of a plane, and we'll talk about planes more in a little bit. But just so you know at this point, a plane is a flat surface. Now, I'm going to go ahead and put 2 dots on this. Those dots represent points. And let's just label them A and B. If I want to tell you that I'm talking about this line and no other line, I can say AB with a little horizontal line drawn above them. Or, nothing says it has to be alphabetical. Nothing says it has to be from left to right. I can call it line BA. Sorry, I'll raise that up a little bit. And sometimes what will happen is there will be a lowercase cursive or script letter near one of the arrows, like this. That's my cursive L in case you don't read cursive well. This would be, and you have to write out the word line L. What is it not the same as? Well, we could list lots of things that it's not the same as. It's not the same as an angle or a circle or a array. There's a whole bunch of things we could name. We're not going to try to name all of them. So lines is one of the building blocks for geometry. All right, let's move on to the next page. This one is a word that we do have a definition for. The word is collinear. And now I get to do one of my favorite things, which is to rag on English spelling. English spelling rules have so many exceptions to them. You know, like the whole I before E except after C. Have you ever heard that? Yeah, except if it's glacier, where it's Glacier. The problem with English is that we borrowed, stole, forcibly had to use, take your pick, words from several different languages. French, German, Norse, Latin. All of those played into making English, which is why English spelling doesn't make any sense. Most other languages, when you learn to spell them, there are defined rules and they stay the same. Why am I ragging on this? Well, there's two L's in the middle here. It looks like it should be collinear, but it's collinear. It's like it's just got a single L. It doesn't make any sense, but we're stuck with it. So, and we're going to be more specific, collinear points. So here's the definition. A group of points is collinear if all of the points are on the same line. And there's an important finisher to that, even if the line is not drawn. Even if no one took the time to draw the line in for us. Let me show you what I'm talking about. So let's draw a line. If you have this diagram, Q, R, and S are pretty obviously collinear, right? They're all on that one line.
T is collinear with all three. I mean, all three of them separately, right?
Right, so T and Q are also collinear. Is the line drawn for you? No, but they're still collinear. Hey, it's just getting hot.
Do you know if he's gone for the day? You know?
I do not know. I'm sorry. So you're exactly right. T and Q, T and R, T and S, those are collinear. So it's whether all of that group exists on one line or not. It is not the same as non-collinear. a set of non-collinear points from this same diagram up here, or this same drawing, would be, for example, T, Q, and R.
Oh,
Are T, Q, and R all on the same line?
no.
No, there is no one line that will contain T, Q, and R. All right, let's move on. So, part of what we're going to be doing is reviewing some algebra concepts and honestly, some fairly straightforward ones. I'm not trying to insult anyone's intelligence. I'm just trying to give us a nice, easy on-ramp, okay? So let's plot these points. A is at coordinates 3, 4. B is at coordinates -1, 0. C is at coordinates -2, 6. D is at coordinates 4, -2. E is at coordinates -2, -3. F is at coordinates 5, 6. So the dots represent points. By the way, we talked about a line has no thickness. What I didn't say is this: a point has no size. A point is infinitely small, smaller than the smallest subatomic particle that you happen to know about. Okay? We use a dot to represent it because we'd like to know where it is. We'd like to, have something that points to it. All right, let's graph line AB and line CD. Because this is really hard to do, I'll draw it by hand, but it's going to be a little squiggly. There's line AB and line CD. Sorry?
Are we making the line like squiggly?
Say it again? Are we
Are we
making?
making the line squiggly?
No, not on purpose. I can't help but do it on this. Now, if you drew yours really carefully, mine's not great. The next question, it's important that these are pretty good. Like I said, mine's pretty bad actually. Find the coordinates of the intersection from part B. Where do these actually intersect if you do it carefully? Yeah, they actually intersect at 1, 2. My first one was pretty good. My second one I had to course correct because I got a little too low. So now I've got a question for you. Is it possible for line AB and line CD to intersect at an additional point other than 1, 2? No. Because if two lines intersect, they only intersect at one point. Then the other question is this: do all lines intersect? No. And it says add this information to the Freyer model for lines. So we're going to go back up to this for lines. I got to spin mine around. Now I'm going to add this over here in properties. If two lines intersect, They intersect at only one point. And we'll also add that not all lines intersect. There are actually two kinds of lines that don't intersect. One of them you undoubtedly have heard of. The other one, maybe not. What kind of lines never intersect? Yes? Parallel lines never intersect. There's another kind of lines that never intersect. Anyone know what the second one is called? I'd be really impressed if anyone knew it. Max? Oh, thought you were holding up your hand. So, if this is a line and this is a line, are these two ever going to intersect each other?
No.
No. Are they parallel?
No.
They're not parallel either. When you get into three-dimensional space, you can make lines that aren't parallel, that don't intersect. Those are called skew lines. They don't intersect, but they aren't parallel either. So like if I draw a line on the floor going from the front of the room to the back of the room, and I drew a line on the ceiling going from side to side, those would be skew lines. They're never going to intersect, but they're not parallel either. Okay. Back to this. All right, are points A and B collinear?
Yes.
Yeah. Why? The easiest answer is they're both on line AB. That's why they are collinear. What about points E and D? Let's see, E is down here and D is over here. Are E and D collinear? Yes. What line are they both on?
ED.
Line ED. Is line ED drawn for you?
No.
No? Does that matter? No. So, if we go back to our Freyer model for just a second, we're going to add this to the properties. Any 2 points, I do mean any 2 points, are collinear. Because you could make a straight path between those 2 points. That makes them linear. All right, back down to the last page. Do lines AB and DE intersect? Do lines AB, which is drawn in for you, and DE, which is not drawn in for you, are they going to intersect?
Yeah.
Yeah, because they're not parallel. Now, next question are C, and I'm going to make these points really big, B and D. Are those 3 points collinear? No. Why?
They're not all on the same line.
Yeah, there is no line that contains C, D, and B. You can have C and D, or D and B, or C and B, but you can't have all 3 on the same line. It's just not possible. Are A, B, and F collinear?
Yes, they're all on line BAF.
Are all these on the same line? Yep. So remember that line keeps going. So yes, they are all on. And you can just call it line AB. You don't have to call it ABF. In fact, mathematicians are kind of lazy, and so they don't ever name all the points on it. They just give 2 of them because that lets you know which line we're talking about. Okay? But that's the logical assumption. Okay. Any questions about that? All right, I have a worksheet for you for your assignment today.